Okay, good morning, class. So from this week on, we're working with three-dimensional modeling. We're not working with 2D drawings anymore. This week's activity is pretty simple. We will just be drawing this shape. No need for dimensions, no need for center lines or line weight changes. We're just gonna try and model it in three-dimensional space and then present it in our layout space. Okay, so shouldn't take more than an hour and a half, 2 hours. If you have any questions, please just let me know. So have you guys had a chance to look at your lab manuals for lab 4 and lab 5? Lab 4 was a basic introduction to some of the three-dimensional tools. So you have the extrusion, the revolution, sweeping, and lofting. And then lab 5 was talking about adding dimensions. So the stuff that's in lab 5, we don't really need to cover. Mostly focused on lab 4 manual. Right. So there are 3 different types of workspaces in AutoCAD. Okay, workspace is different from the model space and the layout space. Model space is where you do your drawing or your modeling. Layout space is where you present it, you put your dimensions, put your title block, do your scale. The workout space, the workspace is the space in which you're working. So we have drafting and annotation, which is what we've been using, and it's the default setting. And then you have 3D basic, and then you have 3D modeling. So if you click on this little arrow up here at the top, you can turn on your workspaces to see what workspace you're working in. And you'll see by default, it's drafting and annotation. You can change that to 3D basic. Right now you have access to a whole bunch of different tools. And these are the tools that we'll be using today. Okay, if you don't have this in your version, this small arrow up here at the top, you can also type in workspace. You can go to settings. And then it'll say my workspace is, and you can change that to 3D modeling or 3D basic. So we're using 3D basic. And then click OK. All right, that's another way to access it if you don't have that little arrow at the top of your screen. Right, so till now we've been working in the XY plane. Now in AutoCAD, you can only draw a flat shape in the XY plane, and then you can either extrude it, revolve it, loft it, or sweep it through that third plane, through that third dimension, which is the Z dimension or the Z axis. All right. So to be able to see all 3 axes, you can go to View. Over here, you have the unsaved view. If you click on that, you can select SW isometric or any one of these isometric options. I'll select the first one. And now you can see your X, Y, and Z axis. You can also access this by clicking on the bottom left corner of your orientation cube. So if you click on this corner, you'll also be able to see the isometric view. Right, so like I mentioned, we can only draw in the XY plane. So we have to be able to move our XY plane or shift it, rotate it, depending on what shape we're trying to draw. Say we were trying to draw a shape on this front surface, okay? So right now XY is aligned with the top surface. So if we draw, it'll be in that XY plane, which is a flat object. You look from the top, flat object, but if you try and look from the side, It's just a bunch of lines. All right, if we were to try and draw on this front surface, so on this side, we'd have to try and rotate our UCS. So UCS stands for user coordinate system. And like most CAD modeling software, it's all done with relation to a Cartesian plane or a coordinate system. In our case, it's a Cartesian plane, so we have X, Y, and Z components. So you have to be able to rotate this X, Y, and Z, depending on what it is you're trying to draw. So if I was trying to draw on this surface, so this front surface, try and draw vertically, I'd have to rotate my UCS. To do that, you can type in the command UCS, right? So this is the UCS command. The first click will place your origin. So if you don't have a drawing on your screen, you can just place that anywhere. But in my case, because I have a drawing here, I'll place it here on the corner. The next click will determine the direction of your x-axis. So I want my x-axis to go in this direction and my y to be vertical. Right? Notice that my grid lines have now changed, so they're now vertical, and I can now draw on this surface. Right? And then if you look from the side, you can see that we have planes that are perpendicular to each other. So I've drawn now on my new XY plane. Right, that's the basic fundamentals of drawing in three-dimensional space. You have to move your UCS to wherever it is you're trying to draw. So if you're trying to draw on a surface, you'd move your UCS origin to somewhere on that surface, set up your XY plane so that it's parallel to that surface, and then you can draw on it. Right, it's a bit confusing, but as we try and work through the activity, it might become a bit more clear. Right, so like I said, you can draw on the XY plane and you can extrude into the Z. But when you're drawing in the XY plane and you're trying to create a surface that you're going to then extrude, you have to use something called a polyline. Right, so a polyline basically creates a bunch of lines that are all joined together. Right? By default, they're all highlighted. If I were to just use a normal line and try and draw the same shape, okay, each one of these lines is individual. In order to be able to extrude, revolve, loft, or sweep a surface, it has to be a closed loop. So this is a closed loop where all the sides are connected to each other and they all end at the same point. Right? You don't have any lines that are overlapping or overhanging. So if you have something that's overhanging, make sure you trim it so that you just have a closed loop. A surface like this, you can then extrude. So if I wanted to try and extrude, extrusion is basically just giving it a thickness. I can do that. If I try and extrude this, a whole bunch of different lines, it'll extrude as a surface. And this is not what we want for three-dimensional modeling. We want it to be extruding as a surface. So if we change, say, our visualization and we look at it as a 3D solid, you'll see that this is a solid surface, whereas this is just a bunch of surfaces. Okay, it's not solid. So that's why we need to make sure our surfaces are all using closed loops. Okay, covered in your lectures were the 4 basic three-dimensional modifying tools. You have the extrusion, which is basically you draw something on a flat surface and then you extrude it up to give it a thickness into that Z axis. You have a revolution where you draw a surface and then you revolve it around an axis. You have lofting where you have 2 different profiles that's set at a different distance, and you can create a nice smooth transition from this profile to this profile. We won't be using that today. And then you have sweeping, which is basically you draw a profile, you define its path, and that profile will follow along that path. Okay, we won't be using this one either. We'll just be using the extrusion and revolution today. Next week, we'll cover the other 2. All right, so let's get started. First thing we're going to do is we're going to set our units. So make sure that we're working in millimeters. Excuse me. Right. So one of the most important skills that you should develop as an engineer or as a drafter is to be able to take any complex three-dimensional shape and break it down into smaller components, which are easy to manage. All right, so we have basic shapes like boxes, cylinders, spheres, cones, pyramids. Okay, those are the basic shapes. So whatever drawing you're given, you try and break it down into those basic shapes, if you can. In some cases, that's not possible. That's where you use your other tools like sweeping and lofting. But if you can break it down into simple shapes, please do, try and do so. So our shape here, if we were to try and draw this straight off the bat, it'd be very difficult to draw. Okay, you have lots of different geometries depending on the view that you're looking at. If you look from the side, it looks different from when you look at the front, look at the top. So what we're going to do is we're going to have to try and break this down into manageable sections. So there's lots of different ways you could break this down. I'll just be demonstrating one, but I urge you, if you have some free time, try and draw it using different methods. Try and draw it using different shapes that you're breaking it down into. So the way I'll break this down is two major shapes. So we have this box section. So this will be 16 by 100 with a height of 35. So this is one box. I'll break it down into, and then I'll draw this all as one shape, one big L. One big L, and then extrude it to a distance of 38. Okay, 38 comes from this radius of this semicircular section here. So the diameter would be 38. That's why we're extruding to a distance of 38. So what I'm going to try and draw first is I'm going to try and draw this L section first. So it'll be 125 by 64 by 25 by 54 by 100 by 10. All these dimensions taken from this drawing, right? But notice if we were to look at our AutoCAD application right now, we have our axis like this with X here, Y here. If we're going to try and draw on this surface, we want our Y to be vertical and our X to be horizontal, which means we're going to have to rotate our UCS. So in your applications, going to type in the UCS command. Okay, I'll put my origin anywhere, doesn't really matter. Rotating or orienting your UCS is made easier if you turn on your ortho mode. So if you turn that on, it'll easily snap to any one of the 6 orientations. So my Z, my X, I'll put in this direction. And my Y, I'll put vertically. All right, so when you orient your UCS, the first click is your origin. Second click is the direction of your X. Third click is the direction of your Y. Okay, if yours is oriented this way, that's fine. If you also orient it the other way, where you have X here and Y here, it's the same thing, right? You're still drawing on the same plane. Okay, so now I'm going to draw that L profile. I'll come up here to my tools. I'll select Polyline and start drawing that profile. So I have 125 with a height of 64. Coming back this way, 25. Down 54. Long 100. And then back to the starting point. Right. So 125 by 64. Right. Then by 25. and then 54. And then 100. And then final distance is 10. Okay, for some of you, when you've started to draw your shape, your line has gone right outside of your screen, yes? Some of you, it's zoomed right in. You're gonna have to zoom out. So if you've created a line and it goes beyond this point, say what, 900? Okay, it's gone beyond. What you're gonna wanna do is you're gonna wanna click on this zoom to extents, which will basically resize your drawing so that you can see the end of that line. And then you can carry on drawing. So you use another polyline to finish off your shape. Right, so my initial shape, it is a closed loop, okay? When I move my mouse over that line, all of them are highlighted. This second one here, it's not a closed loop, okay? These lines are all connected, but this line is separate. Now, if your drawing is like this, it doesn't mean it's wrong. You just have to make sure that this line is joined to this line. So what you can do is you can highlight all of the lines that are not connected, type in join, press enter, and then they all become joined. Right, once we have this L profile, we can go ahead and select the extrude tool. So extrude is up here in create, or you can type in extrude. You then select the surface that you want to extrude, press enter, and then specify the extrusion distance. So extrusion distance is 38. And you have a solid. You want to make sure that it's solid, you can always just change the way that you visualize it. Right, so we have our first shape. Like I mentioned, we're breaking this down into 2 different shapes. So this is our first one, the L, and then we have this box that we have to draw as well. Now this box sits on top of this surface. So we have to move our UCS, which is currently somewhere here, to be on this surface somewhere. So what we're going to do is we're going to type in UCS. We're going to move it to any one of these 4 points on this surface. So you got the 4 corners. I'll move my UCS maybe to this corner. I want to make sure that my XY plane is parallel with this surface. So I can put X here, I can put X here, it doesn't matter. So I'll put my X here and then my Y on this side. So you'll notice now that the XY plane is parallel to that surface with the origin on that surface, meaning I can now draw on this surface. So what I'm going to draw is I'm going to draw a rectangle, 16 by 100, and then extrude it the height of 35. So again, using polylines, draw my box 16 by 100. Right? Closed rectangle, and then I'll extrude that the height of 35. So again, UCS, move my origin to anywhere on the surface. So I can select any corner. I'll select this one this time. My X, I'll put this side or this side. Doesn't really matter. So I'm going to select this side. And then my Y, I'll select the other side. All right, my XY plane again is parallel to this surface. The origin is on that surface. So I can now draw on this surface. I'll go ahead, select my polyline tool, and draw my shape. Okay, like I mentioned, there's lots of different ways you can draw this shape. All right, this is just one way that you can do it. Again, you could break this down instead of just 2 shapes, you could break it down into 3 different rectangles or 3 different box sections. So instead of drawing the surface and then extruding, you can actually just select one of the basic commands. So these are the basic shapes. Like I said, box, cylinder, cone, sphere, pyramid, wedge, torus and polysolid. Okay, so these are all the basic shapes. Not so much these two, but the rest. So we can select box and we draw our box profile. So the shape that we were trying to draw could be broken down into something that is 38 by 100, extruded to a height of 10. Another box could be drawn, which is 38 by 25, extruded to a height of 64. And then we could just move these shapes together. Okay. Same profile as this shape, just a different method. Okay, if you're trying to use the box command and you want to try and set a certain dimension. So right now highlighted in blue is the width. If I can set that distance, so I'll set it to 38. Don't press enter, you can press tab and you'll be able to shift to the other side that you want to try and dimension. So I want the other side to be 100. Once both sides are defined, then I press enter. So tab is the button that you'd press to be able to shift between the different lengths that you want to assign. Okay, this session is being recorded. So if you want to go back and watch the recording, see how I drew this, then you can. All right, now we have. Oh. Right, so we have two shapes here. We have this L-shaped bracket, and then this box that's sitting on top of it. What we want to try and do is we want to try and join these two shapes to become one. So the command we're going to use is the union command. So you can either select union or you can type in union. Select the different shapes that you want to join, and then press enter. Okay, now it's all become one shape. So again, union, select all the shapes you want to join, then press enter. Okay. Notice that this method where I drew it using individual boxes is the same as when we draw the L shape. And then if I do the same for this one, union. Okay. All the same thing. Only difference for this one is this is a height of 83 instead of 64. That'll be clear in a minute, but okay. If you guys are just drawing this one, that's fine. I'm just demonstrating the other methods that you can use to achieve the same shape. So the command is union. Okay, so you can select union here, highlight the shapes that you want to join, and then press enter. So the next thing we're going to try and do is we're going to try and draw that semicircle shape that fits on top of this surface. Okay. So what we're going to have to try and do is we're going to draw a distance of an angle of 180 degrees. So first things first, you have to move your UCS to that surface. So type in UCS, put your origin anywhere on that surface. So I'll select this corner here. Make sure your X and Y are parallel to that surface. So I'll put X here and Y here. Okay, so my XY plane is now parallel to that surface. I'll then use my polylines to draw a rectangle that is half that area. Okay, so I have a rectangle on top of that surface. If you turn on your snaps, you turn on midpoint, you'll be able to draw this a lot quicker. Okay, so once you have this rectangle, you can then use the revolve command. So you can select revolve or type in revolve. The object to revolve is this profile. Press enter. It says to define the axis. The axis is along this line here. So I'm going to select 1 point here, 1 point here, right? And now my angle, because I'm revolving it counterclockwise, will be a negative 180. So minus 180. And you now have a semicircle on top of your surface. So again, moving my UCS to this surface, anywhere on this surface. Okay, I'll select this point now. My X in line, my Y in line. Okay, so my XY plane is in line with that surface. I'll now draw a rectangle that is half this area. So using my midpoint tool and my snap cursors, I can draw a rectangle. Okay, draw my rectangle, and then I will revolve it around this line. So revolve, define the axis, so 1, 2, and my angle will be minus 180. Okay, you can see that it's a semicircle sitting on top of that shape. Okay, there are lots of different ways to achieve this same look. So another way is to draw a cylinder and then place it in line with this surface. So I would move my UCS to this line here. Make sure my X and Y are parallel to this surface. I'll now draw a cylinder. And then extrude this cylinder, extrude this circle to create a cylinder. Extruded distance of 25. So I have the same sort of thing. All right, same sort of look. I can also use fillet tool, so I can fillet, select my edge, set my radius to 19. Okay. So there are lots of different ways to end up with the same sort of look. Just depends which method you choose. Okay, again, this session is being recorded. So I'm going over these methods very quickly. If you want a bit more detailed, you can watch the recording. Remote students, are you able to hear me okay? Okay, great. I noticed you guys joined a little bit late today. No worries, the recording will be put up, and like usual, your submissions will be a lot later. Okay, so I'm in the process of getting my staff email address, but for now, if you have any questions, you can email me at this address. Okay, so we're focusing on this one. These two are just examples. Okay, we want this semicircular shape to be joined with this one, so we'll use the union command again. So union, this one, and this one, enter, all becomes one shape. Right, so we've discussed how to join shapes. The next most important command to be able to do is to be able to subtract shapes. So our shape right now is made up of a combination of this L solid and then this box sitting on top of it, along with this semicircular dome. Now we're going to draw each one of these cylinders, 1, 2, 3, and then this rectangular slot as individual members, and then we're going to subtract it from the overall shape. So I'll demonstrate this one, and you guys will do the other 3. So I want to draw on this surface. I want to draw a circle on this surface. So I'm going to move my UCS to somewhere on this surface. So I'll type in UCS. I'll move my origin to any point on this surface. Let's say this point here. I'll set my X and Y so that it's parallel with that surface. So my X I'll put up, Y I'll put this side. So my XY plane is now parallel with this surface. I'll go ahead and draw my circle. So I'll just use construction lines. So for my construction lines, I'll just use normal lines so that I can delete them easily. So just a normal line to my center, and then draw my circle. Circle with a radius of 9.5. Okay. Be sure if you use construction lines like this, you delete them before you do your extrusion. So I'll delete this one and then extrude my circle to make it a cylinder. I'll extrude it a distance of 25. So right now what we're looking at, we're still looking at a solid shape. Okay, I just have a cylinder in here. If I change the view again, okay, we have a cylinder, but it's just sitting inside. Okay, I haven't subtracted it yet. So what we're going to do now is we're going to subtract this cylinder from this overall shape. So next to the union command, you have subtract. If you select subtract, the first thing that you're going to highlight is the shape that you want to subtract from. Okay, so down here it says here, select the objects. So the object to subtract from is the larger shape. Click on it, press enter, and then it says to highlight the surfaces, solids, and regions to subtract. So I want to subtract this cylinder. Click enter, and now I've created a hollow hole in my member. Okay, right, there's a hole now. So the subtract command is very useful in removing shapes from larger shapes that you have. So again, subtract tool, subtract, select the larger object, press enter, select the smaller object, press enter, and they all become one shape. All right, so you'll use the same method of moving your UCS to the surface that you want to draw on, extruding that shape, and then subtracting it for the holes down here and the slot over here. Okay, so remote students, this is the final submission format. Okay, just show your display it as a 2D wireframe. Okay, don't need to change any of the line weights. Don't have to change the line type. Don't have to project hidden or delete hidden. So this is the final submission format. 7 marks will be for your drawing. So we will check that is we will go and we will measure different components of your drawing to see whether or not it's correct. Then 2 marks will be given for your title block. Title block being making sure that these dimensions are correct. So I think it's 277 by 190. Making sure that all your text is centered in the block as well as big enough or small, not too big, not too small. And then the last mark will be given for your scale. So if you select the scale in your viewport of 1:1, it should also be shown in your title block. All right, so this lab is very simple, very straightforward, just those basic commands. So drawing profiles, extruding profiles, unionizing different shapes, and then subtracting shapes from larger shapes. Those are the basic commands that we covered today. Okay, so this session will end in, I'll end this session now and upload this recording either this evening or tomorrow morning, and then you can carry on with the activity. If you have any questions, please do try and contact me or or any one of the other tutors or lab demonstrators. Okay, in case you didn't get my email address, this is my email address. If you have any questions, please send them to me. Regarding late submissions, you guys don't have to worry about that. All right. Any questions before I end the session? Okay, thank you very much. You guys have a good day.